Alright, so the last thing that we're going to look at when we graph sine and cosine are horizontal shifts. And so the only letter that we haven't looked at yet is this C. And so the C represents a horizontal shift in the function. So this one is the one that takes the most work to do. But to graph the function, you're still going to need the period and the amplitude. So that part doesn't change. And then the phase shift points are what is new. And so if you ever see the word phase shift, that's just a really fancy way of saying horizontal shift. Like if it's got a phase shift, it's going to be shifted to the left or the right. And so we need where the points are going to be after we shift the function left or right. And so if you go back to transformations that you did in Algebra 2, like if you had this function, x minus 2 squared, and you graph that, this graph of this function took this original graph of x squared, the parabola, and it shifted it. So if you were to graph this, this would actually, you would think that it would shift it to the left because of this negative, but it actually is going to shift it to the right too. So instead of that point being right there, the vertex, now it would be right here, and that would be your new graph. Okay, same thing if you had x plus 2 squared. This would take the graph of the parabola, and instead of shifting it to the right 2 like you would think, it would actually shift it to the left 2. And so your parabola would be right here. And so same thing applies whenever you've got any function, sine, cosine, doesn't matter. If this is, let's go to the next slide. If this is positive, this is actually going to shift it to the left pi units. Okay, and so let's go ahead and look at graphing this. So the amplitude is going to be 1/2. The period, I'm going to put 2 pi over the number in front of x, and so that's just going to be 1. And so that just gives me the period is 2 pi. And now, I'm going to go ahead and write this down. This is going to be a shift to the left pi units. And the easiest way that I found to do this is to look at where your old points would be based on this period value. So I'm going to go down here and I'm going to draw this out. So if I were to graph this normally, then I would go out to 2 pi, negative 2 pi. And then my middle point would be at pi and negative pi. But now, and then this point you can't forget about 0. That's a point that we always graph to. And so when I go left pi units, what I'm really doing to each of these values is where the point would be at negative 2 pi, I'm going to subtract pi from it, and now that's where that point is going to go. And so I'm going to take each one of these values and subtract pi from it. And so when I do that, it's going to give me the new values of the points that I need to graph. And so I'm going to come down here. This is going to be at negative 3 pi. And then I'm going to always make sure I don't want to forget about any points, so I'm going to put a dash where I'm going to have one in my original. So I would have negative 3 pi and then a dash. And then this would become negative 2 pi, and then I would have a dash. And then 0 would go to negative pi, and then I would have a dash. And then pi minus pi would be my new 0, and then I've got a dash. And then that point at 2 pi minus pi is just going to be pi. And so then here are my new points, and then the x-axis, or not the x-axis, but the y-axis, would be right here at 0. And so then I'm going to go label these points on my graph up here. And so to the right, I'm going to have a dash and then pi. I'm going to go ahead and label 0. I'm going to have a dash and then pi. This would be negative pi. Dash and then negative 2 pi. Then a dash and then negative 3 pi. Alright, and so then those are, getting the points on there I think is the hardest part. And so once you get these points on there, I know this is a sine function, And I know that sine normally starts at the origin, and I'm going to go ahead and label this is going to go up to 1/2 and down to -1/2 for its maxes and mins. And so normally if I come down here and I graph this, I would normally start at a 0. But now I'm going to have to look and see where this point that was at 0 actually went. So when I subtracted pi from 0, that's going to push this point back to -pi. So at -pi is really where that 0 is going to be. And so then once you get that point, that first point, the rest of your graph should fall out pretty nicely, because I'm going to go ahead and subtract pi from that 0. That's where the first point or the start point goes. And then to the right, I would go up to a max. So I'm going to do the same thing. To the right, I'm going to go up to a max because this is positive. And then my next point would be a 0, then a min, back to a 0. And so there's one period of this sine function that's been shifted. And now just like I would normally, I'm going to go back the opposite direction, and so I would go down first to a min, so then down to a min, 0, max, 0, and so then here's my other, here's my other side of this sine function. I'm going to just redraw this. And so then that's what it looks like with the shift. Alright, let's do a couple more of these. Alright, so amplitude is 2/3. The period, and the period for, I'm not going to give you a period change and a phase shift in the same function. So the period is pretty much going to just stay the same. 2 pi over, this value is 1, so that's just 2 pi. Alright, this time I'm going to the right 2 pi units. So I'm going right 2 pi. And so, just like I did before, I'm going to come down here and put all of the original points on the graph. And so then I'm going to take these right 2 pi. And so when I take these right 2 pi, and I'm going to label 0, I'm going to add 2 pi to each of these. So when I add 2 pi to each of these, I'm going to go actually do that. It helps me to write this out so I can see what's happening and to draw it out. If I don't, I forget a dash or my whole graph looks like crap. So on this line, -2 pi plus 2 pi is just going to be 0. So here is my new y-axis. That's where the y-axis is. And then I have a dash that I can't forget about. -pi plus 2 pi is just going to be at pi. And then I have this dash. And then 0 plus 2 pi is going to be at 2 pi. And then I have this dash. And then pi plus 2 pi would be at 3 pi. Then I have a dash. And then 2 pi plus 2 pi is going to be at 4 pi. And so then pretty much this entire graph is to the right of the y-axis. And so then I'm going to go label that. And so this is 0. I'm going to put a dash and then pi. Dash and then 2 pi. Dash and then 3 pi. Dash and then 4 pi. My points are not perfect, but this is what you should have, okay, in these numbers. So then I'm going to graph this. This is a cosine. The amplitude is 2/3 and -2/3. And so then cosine is always going to start at a max. And so I've got to think, where did that point that was my original start point go? So I would normally start at 0 up at a max, since this is cosine. But that point, 0 plus 2 pi, gave me this value right here. And so at 2 pi is really where that max value should start. So at 2 pi, I'm going to start at a max and then graph to the right and left like I would normally do. So normally I would go down through a 0 and then a min. So I'm going to go down through a 0, then a min, then a 0, then a max. So that's what the first period of this function looks like. And then I'm going to go back to the left. And so then I would go down through a 0, then a min, 0, max. And so here's what my cosine function looks like. Alright. Try this one on your own. Go ahead and hit pause. But then you can come back and watch me do this one. This one's a little tricky because there's a fraction there, but you should still be able to do it the same way that we've been doing it. So I'm going to write down the amplitude. Amplitude is 2. the period is just going to be 2 pi over 1, since this is 1, but it's really not going to change anything, so period is just 2 pi. This is flipped because I've got a negative in front, so I'm going to write that to remind myself. And then this is going to be shifted to the left pi over 2 units. And so when I go find my new points, I'm going to put 2 pi out here, pi dashes 0, negative 2 pi dashes negative pi. Alright, and so then I'm going to go left pi over 2, so that means I'm going to subtract pi over 2 from each one of these. So I'm going to go write that, subtract pi over 2 from each of these. Alright, and so when I go get my new points now, this negative 2 pi minus pi over 2, this is just like what we did whenever we had to get a common denominator. And so I'm going to go ahead and get a common denominator. This would be a 2 in the bottom, and then if I put a 2 in the top, that would become a 4. So I've really got 4 pi over 2. And so when I subtract these, this is negative 4 minus 1, so this would be a negative 5 pi over 2. And then I've got a dash right there, so dash. Now, negative pi minus pi over 2. If I get a common denominator and put a 2 in the bottom and a 2 in the top, that'd be negative 2 minus 1, which is just going to give me a negative 3 pi minus 2. And then I've got a dash. And then 0 minus pi over 2, that's real easy to do. It's just going to be negative pi over 2. And then I've got a dash. And then pi, subtract pi over 2. If I get a common denominator, put a 2 in the bottom and a 2 in the top. 2 pi minus pi is just going to give me a 1 pi over 2. Then I've got this dash. And then 2 pi minus pi over 2. If I get a common denominator, that's just going to give me, put a 2 in the bottom. 2 times 2 would be 4 in the top. So 4 minus 1 would be 3 pi over 2. Now, you should be wondering, hey, I normally start at 0, but 0 is not in my new point. So where is 0? And so if you look, 0 is always going to be in between your negative number and positive number. So negative pi over 2 and positive pi over 2, the middle number right here is where your y-axis should be. And so right up here, this is my y-axis, and so to the left I'm going to label these points, and to the right I'm going to label these 3. So to the left, let's label, we've got a negative pi over 2, then a dash, then we had a negative 3 pi over 2, then a dash, then a negative 5 pi over 2. And so then those are my numbers to the left of the y-axis. And then to the right I had pi over 2, dash, and then 3 pi, not over 3, but over 2. And so then I'm going to look at where I would normally start this function. Let's label the amplitude first. So I'm going to go up to 2, down to negative 2. And so remember, cosine, this is a cosine, so it would start at a max, but since it's negative, it's going to start at a min. So right here at 0, I would start normally at a min. But since that point moved to negative pi over 2, I'm going to move that point over to right there. And so then I'll just graph it the same way I would normally. So normally after that, to the right, I would go up through a 0, then a max. And so I'm going to do that. So 0. Oh, whoops, I forgot my y-axis there. So my next point, I started at negative pi over 2. The next place that we go to is right here on the y-axis. And so I would normally go up to through a 0 right there, then a max, then a 0, then a min. So here's my first, or my positive period, or one of the periods of this cosine function. And don't do what I did. I forgot this y-axis and went straight to this point. But this is always a point that we have to graph, okay, on the y-axis. So then to the left, I'm going to do the same thing I did over here. I'm going to go up through a 0, then through a max, 0, min. Now I want you to notice, because we shifted